Chris clapped too hard on the clapperboard and broke it. Hi, I'm Steve from 123D. Today we are going to do a video that's a little bit different. Basically, we're going to go over some routine maintenance for your 3D printer. Throughout the many years that I've now been 3D printing, I have learned that 3D printer maintenance is a key part of owning a 3D printer. We have picked this machine because there's still technology that is used on this machine on newer machines, so we thought it would be a prime machine to showcase. Modern printers are pretty much plug and play, but that isn't plug and forget. You do need to do some routine maintenance from time to time to make sure that your printer is performing to its optimal performance and causing you no issues in terms of tolerance, print quality and everything else that you would expect from a machine. We've gone back in time. Some of you may be familiar with this machine, others may not, may look at it and think, yeah, it's a Bedslinger. I haven't really seen it before, but ultimately there are some key differences between this machine and the newer machines, but some transition across to newer machines as well. So depending on what model printer you have, we will try and cover as many aspects between the two machines that we are going to show you some maintenance on. So this one here is a Creality Ender 3 S1. Now the reason I picked this machine is because it does have eccentric nuts. So in simple terms, an eccentric nut is a nut, and if you imagine the hole in the nut is off center. Now what this actually does is it acts like a cam, so when you turn the nut with a spanner, it will move the object that the bolt is running through side to side. And as you can see, we have a bit of a slop, especially on the extruder. Now if your extruder is showing this kind of movement, then I would wholeheartedly suggest that you adjust it, because that is going to give you really poor print quality, to the point it might even fail when you're trying to do bed leveling or whatever. So I will show you, I will use the camera to get some close-up of an eccentric nut. So if you can see here, we have a little nut and we have another little nut here. Now very carefully, this one isn't too bad. I'm trying to move the wheel and there's a little bit of friction, so what I tend to do, just slacken it off. If you turn them 360 degree full rotation, it will back off and come back round, but a little bit at a time. It's still very tight. Andrew, what have you done? The big Welshman broke it. There we go. So there, now I can freely turn it. I'll go a little bit more. You just want it to adjust the wheel, so you can basically move it with your fingers on the actual rail, and that is set perfect. So the other side, because I've tightened it up, what it's done is it's basically pulled the extrusions in a touch. So I will repeat the same. Again, perfect. I can feel a little bit of friction, but it's not that loose that you've got loads of free play. So the next one is under there. So again, just carefully adjust that little nut until you can rotate the wheel, as I've already mentioned, and you can see I've taken all of the play now out of that axis, which is what we want. You also do get them on the bed, which is a little bit hard to show on this machine. If you look under there, I don't know if you'll actually see this, Chris, or not, but I'm sure with your editing skills you'll manage. There is two more nuts under there. So basically the extrusion here, the wheels run in that extrusion, so if you've got any play again in your bed, it's always worth checking those. Once you've got all the free play out of your machine, this will happen through wear. So basically you're wearing down the nylon wheels and you're taking out that wear with the adjustment of the eccentric nut. So that is part one. That is the first thing that you want to check. If you're noticing any slight layer lines, extreme cases, you might get layer shift. We've just been doomed into darkness. Who turned out the lights? But typically if you're looking at the wheels and you notice any play and there is a nut on that wheel, that is probably a good sign that it is an eccentric nut. So that is that part done. The next thing that you will want to do is check your belt tension. If you get layer shifts, or you notice grinding, or you can clearly see skipping, then that's a good indication that you need to tension your belt. On this machine, on both axes, this is really very easy. You have a knob on the front. So if you turn the knob, we are tightening the belt, wind it back the other way, and you're loosening. So what you're aiming for is Not overly tight tension. You don't want to go mad because all you'll do is stretch the belt and potentially snap it. You basically tighten into a level where you can hear tension when you pluck it. If you don't get no plong when you pluck the belt, that is definitely a sign that it's too loose. So nip it back up, and that I would call the optimal tone for the correct belt tension. On your x-axis, same again on this machine, we've got a little knob. Basically grab underneath the machine, give it a little bit of a push, and that is pretty good. So that is your belt tensioning on this type of machine. Some machines don't have the knob. You will find a little hex bolt, Allen key adjustment. So again, consult with your manual for your printer and it will indicate how to tension the belts. The next thing you would want to pay attention to, and I'll spin it around so you can get a good view, is your lead screws. Lead screws do pick up dirt and grime and whatever else, and how this will transition into your prints. If you've got dirty lead screws, you'll basically end up with banding all the way up your print. And what causes this is an accumulation of dirt and grime sticking to the grease that is applied to your lead screws, and it makes the actual motion rough and to a point jerky, if you imagine. So every time it still moves, but there is resistance, so that will transition in lines that way, banding. It's really, really important to make sure that you keep your lead screws clean and lubricated. Now, the best way to do this is to get yourself a bottle of IPA, isopropyl alcohol, as close to 99.9 as you can. Get yourself some paper towel, put a bit of IPA on the paper towel and wipe all of the excess grease off your lead screws, making sure they're nice and clean. And then with some lube, you would then want to apply a little amount. You don't want to cake it, you don't want it covered, plastered all over. You literally just want to smear. And then if you then run up and down, that will actually work the grease into the lead screw, and obviously then you can carry on. You are golden. So that is how to lube your lead screws. The next thing, nozzles. A lot of people neglect this part because they believe with modern machines, to a certain extent, they have a nozzle cleaning function, which they do. You still want to periodically clean the nozzle because the nozzle cleaning function that is built into a lot of printers isn't thorough. It removes like the blob from the end. It doesn't give it a proper clean. And for people that are printing with a lot of PETG and whatever else, it's quite a sticky material. They will notice quite quickly that their nozzle is becoming very gunked up with excess filament. Yeah. So the best way to do that, preheat your nozzle, lift the extruder up from the bed and take yourself a wire brush while the nozzle's hot. Literally just go on it and give it a good clean to remove any excess filament that's hardened off on there. I say do it while it's hot because otherwise you will not get it off with a wire brush if the hot end is still cold. If you're typically printing with PLA, heat it to PLA temperature. PETG, heat it to PETG temperature, so on and so on. That is basically how to clean your nozzle. The next thing that a lot of people overlook is actually keeping your build plate clean. Over a period of time, if you're doing maintenance on your machine, like we've already mentioned, lubing your lead screws, you touch the plate, you then transition the grease that's off your fingers onto the build plate. And plastic does not like to stick to anything with a greasy film. The best surefire way to do this is take the build plate off, take it to your kitchen sink, wash it with some warm soapy water, or you can also use, again, IPA to clean the plate. Some plates, they recommend you don't use that. Consult with the manufacturer of your build plate and they will stipulate what to use to clean it. That is very, very important. Make sure you keep your bed clean, your nozzle clean, your lead screws lubed, your eccentric nuts tightened for your V-wheels, your belts are all tensioned correctly, and you will be golden. Apart from that, you know, common sense things, if you've got like remnants of filament all over your printer and whatever else, just give it a clean. You know, get yourself a little clean paintbrush or whatever, dust it all off, even a small hoover with a little brush attachment on it to give it a good clean. Make sure you periodically do that, keep it clean. You look after your machine will look after you. Now, we shall move on. Here, we have a limit switch. As you can see here, you can hear the clickety click. We have one there, and we also have another one hidden here, which you can hear. These will use a mechanical switch to actually sense when the machine is hit its end point, whereas modern machines will rely heavily on the belt tension feedback to the stepper motor, which will in turn tell the machine it has hit its end stop or its end point. In some instances I have seen where it's been reported my machine's tried to home and all I'm getting is a horrible grinding noise. The first thing to check, limit switch. A couple of things can happen. You could damage the wire. It might have come loose from the actual plug where it's plugged in, so check the port. Or in very extreme cases that I have seen with rough handling is the actual metal arm that pivots onto the actual switch itself has been broken off or come away, so it hasn't got anything to actually physically trigger the switch. So here we have selected the Elegoo Century Carbon. The reason I picked this machine is it's a typical CoreXY configuration. So the maintenance aspects of this machine are a little bit different over your traditional bed slinger. But again, I will cover all of the facts and I will try and give you an insight into the differences in 1, the components, and 2, the technology.
We have technology!
CoreXY. The extruder moves from the X and the Y axis, and the bed literally travels on the Z axis. Normally, on most common CoreXY configuration machines, the extruder will travel on either smooth rods or it will travel on a linear rail with a linear bearing attached to the rail, which is then in turn fixed to the extruder. This one, we have smooth rods, so the extruder moves left and right on the smooth rods. Now, I've seen this so many times in the past. Depending upon what bearings are actually fitted to the extruder, travel along the smooth rods, people seem adamantly convinced that you need to apply copious amounts of grease to give you the least amount of friction. That isn't strictly true. A lot of manufacturers use self-lubricating bearings. So basically inside the bearing there is graphite. The graphite lubricates the rail, and by applying extra lube to the smooth rod you basically clog the graphite and render the bearing useless. So again, it's really important to check with your own printer manufacturer's instructions to find out what maintenance they suggest and when. But typically you want to ensure everything that has anything moving across it or is a moving part is kept clean and lightly lubricated. For the sake of this video, I can tell you straight away that there is a very small amount of grease on the actual smooth rails for the extruder axis, so that would be a critical part that you would want to maintain and make sure it's kept clean. And again, really simple guys, get yourself paper towel, get yourself some IPA, literally give it a good clean, remove all the old grease from the smooth rods, make sure you slide the extruder over so you can get the other end, and then literally put a very liberal amount of lubrication, super lube, on the smooth rods, and then work the extruder left to right to basically spread that grease out and give it a very light coating all over. But again, check with your manufacturer's instructions first before you do that, because especially on the Creality K1 series, I do know that they are graphite bearings which don't need lubrication, and by applying lubrication to them smooth rods on that machine you will clog the bearing, rendering it useless. So always check before. Then we have the Y-axis movement. Again, on this machine is traveling on more smooth rods. So as you can see here, we have one that side and we have another that side. And if you get a cheeky look in there, you can see the actual bearing sat inside that plastic block. And looking at this bearing, I would put money on there are ball bearings inside there, not graphite self-lubricating bearings. So these will have grease packed in there from the factory, but you still want to maintain that you keep these rods clean and very liberally apply, you know, a small smear of grease across those from time to time to make sure everything remains smooth, silky smooth. I will come around the front. Here you can see that the Z-axis is actually driven again on a smooth rod with the same sort of bearing, but it's driven with a lead screw, not a belt. And if you look at the top of the lead screw, you can see there is a little pocket of grease. And basically what that will do is, as the bed travels up and down, it will lubricate the lead screw. You can tell when these are really, really dirty because you will start to see that the grease becomes really black and dirty. In some extreme cases, I've seen it where it actually picks up wisps of filament and they stick to it. Basically, when the thread passes through the lead screw nut here, it will gunk that up and make your motion rough. You will see that in banding. Depending on how dirty that is, or how far up the actual screw the dirt is, it will vary on the actual banding that you will see on your print. If it's hanging all the way from top to bottom, you will get that repeated all the way up. If you've got like little bits here and there, you'll like get random banding lines. Really, really important to check those are kept nice and clean and lightly greased. And you've got another one there in the back, and as you can see, with a smooth rod and a lead screw. That is typical lubrication maintenance for a CoreXY. So what you might find is when you home your machine or your machine's homing, the extruder or the bed travels to one extremity and basically grinds when it hits the end because it doesn't actually know that it's there. So that is a telltale sign if your belts need to be tensioned. And if they do, consult with your manufacturer's handbook because they will give you detailed how to tension your belts on that model of machine. Every machine is slightly different. The principle's the same across the board, but each manufacturer has very slight discrepancies in between how they adjust their belts compared to another manufacturer. Consult with your manual. That will show you how to adjust, where to adjust, and give you an idea of what sort of tension you should be adjusting to. General rule of thumb, if you pluck the belt and you can hear like a nice tone, you can feel a bit of ping in it.
The bell, once, that's all it takes, not ping, ping, ping.
Then you know that the belts are tight and probably don't need touching. If they're really, really slack, they won't make a ping at all, then definitely they need to either be replaced if you've tightened them up as much as you can, or just tightened. So again, you need to really check that and keep an eye on it. Periodic maintenance, once a month, just check your belt tension. I tend to find that with enclosed machines like the CoreXY, if you're printing a lot with ABS or high temperature filaments that require a decent ambient chamber temperature, the belts need adjusting a little bit more often than what they would if you were printing with the lid off with PLA, for instance. And again, it's due to the heat, it's stretching things. Take that into account. If you see any of those things start to show on your print or your calibrations fail or whatever else, check your belt tension. Top tip. Next up, nozzle. Again, cleaning the nozzle on your CoreXY is exactly the same as it would be on a Bedslinger. Turn the machine on, preheat it to the temperature of the last filament or your most used filament, get your wire brush and give the nozzle a really good clean. If you want to, you can remove the silicone sock prior to doing this. My only tip if you were doing that is be very careful if you've got any thermistor wires or heater core wires there. You don't really want to scuff them up with your wire brush and potentially damage them, so do take a bit of care when you're doing it. But just make sure you give it a good scrub, get all the excess filament off there, and you will find that your prints print a lot nicer. If you do need to replace your nozzle, depending on what machine you have, a lot of machines now have what they class as a quick remove nozzle. If your nozzle requires unscrewing the actual nozzle from your heat break, it is imperative that you do this while the machine is unloaded of filament and hot, because what you've got to accept is, regardless of there's being any filament in there or not, there will be remnants of cool filament that will basically fuse the nozzle into the heat break. So if you try and do this cold, the chances are you are going to shear the nozzle off, and you'll end up then with an absolute nightmare trying to get the rest of it out, or worse still, having to buy a new heat break for your machine because you can't get the threaded part of your nozzle out. Heat the nozzle, let it sit cooking for a little while, grab your wrench that you will have got with your printer, it's like an angled socket in most cases, purposely made for your nozzle, and remove it while it's hot. And then once it's removed, you can then let it cool down before you refit your new one. Refitting a new one cold is fine. Undoing an old one cold is not fine. Do not Do it, ladies and gentlemen. Build plates, exactly the same principle applies. Keep it clean. You don't want grease on there. You don't want layers and layers of glue building up. Take it off every now and again. Give it a good clean. Make it look nice and shiny and new again. Reapply your glue stick if you want, or 3D lac spray that we tend to use. That will just save you having print come off mid-print, sticking to your hot end, or filling your chamber with spaghetti. Not a nice look. The biggest take home that I can give from my personal experience into 3D printing, whether you own one printer or 101 printers, is just keep them clean. There's been so many times that I've had machines come back in for repair or warranty work or whatever that aren't very old, that are absolutely hanging in polite terms. There's like remnants of filament all over the base of the machine, and it's not good. I mean, what you have to take into account is there's a lot of moving parts within a printer, and yes, they are precision tools. You need to keep it clean. A clean tool is a happy tool. So, I hope you've enjoyed the video, you found it useful and informative. We will be doing some more videos along these lines going forward, so please don't forget to like, subscribe and share. For this one, that is me, out. I will see you on the next one. Bye bye for now.
As always, we aim to have the most competitive 3D printer prices on the market. If you see any of our printers being sold by a mainstream retailer for less, please drop us an email using the link in the description and we'll do our very best to beat their price. Also, if you're watching from outside the UK, check the description for links to our European 123 3D sister stores.